Assalamu alaikum wa rahmatullahi wa barakatuh, dear students. Firstly, I would like to welcome you in the course Basic Mathematics. I am Dr. Tawfiq Al-Gilani. In this video, we are going to cover all lectures for week 1. Actually, all topics in the Basic Mathematics you already have studied when you was in the school. The first topic is number sets. First number sets is the natural number. The whole numbers from 1 upward, 1, 2, 3 and so on, they are called natural number. Or from 0 upwards in some fields of mathematics, 1, 2, 3, 4, 5 and so on. No negative numbers and no fraction include in natural number. We can present the set of natural number is denoted by capital N, and we can represent a natural number in number line like this one. Also, there is integers number. Integers are like whole numbers, but they also include negative numbers, but still no fractions allowed. The set of integers numbers is denoted by capital Z. So integers can be negative, -1, -2, -3, -4, -6 and so on, or positive and positive number 1, 2, 3, 4, 5 and so on, and also include 0. We can put all it together like this: integers between the bracket, curly bracket, so 0, 1, 2, 3, 4, 5 and so on, -1, -2, -3, or we can present by this number line. For example, -16, -3, 0, 1 and 198 are all integers, but 3/4, 3/4, 1.1 and 3.5 are not integers, as these are fractions. Rational number. A rational number is a number that can be in the form a over b, where a and b are integers and b is not equal to 0. The set of rational number is denoted by capital Q. For example, 5 is a rational number. Why? As we can represent 5 as a over b, like 5 over 1, and a is belong to integer numbers and b 1 is belong to integer numbers, and the b is not equal to 0. Also 7 over 4. This is an improper fraction because the numerator 7 is greater than denominator 4. -1 over 10. This is a proper fraction. Why? Because the numerator -1 is less than denominator 10. Also 1 over 9. This is a proper fraction again because the numerator is less than denominator, and these are all rational numbers as we can put as a over b. Irrational number. An irrational number is an integer number that cannot be written as a simple fraction a over b. Irrational means not rational. The set of irrational numbers is denoted by capital Q dash. Pi is an example of an irrational number because pi is equal 3.1 blah blah blah, so and more. So the decimal goes on forever without repeating and without stopping. The square root of 2 is an irrational number. Why? Because we cannot write the square root of 2 using ratio as fraction a over b of two numbers. Real numbers. Real numbers include whole numbers, rational numbers, and irrational numbers. The set of real numbers is denoted by capital R, and we can represent the real numbers by the the number line like this one. Complex numbers. A complex number is a combination of a real number and an imaginary number I square equals -1. The set of complex number is denoted by capital C. This set contains all numbers of the form a plus bi. A is the real part and B is imaginary part, and I equal to square root of minus 1. Example, 1 plus I. So A is 1, real number, real part, and imaginary part B is 1 here. For example, here 39 plus 3i. So real number A is 39 and imaginary part B is 3. For example, here minus 2 plus by I. Uh, Real part A is minus 2 and imaginary part B is by. For example, here square root of 2 plus I over square root of 2. The real part A is equal square root of 2 and imaginary part B is 1 over square root of 2. Prime numbers. A prime number is a whole number that cannot be made by multiplying other whole number. The set of prime number is denoted by capital P. So P is between bracket, as I said, 2, 3, 5, 7, 11, 13, 17, and so on. Notice 1 is not a prime number because it cannot be multiplied by 1 times another 1. So 1 times 1. So they are same numbers. Example, is 8 a prime number? No. Why? Because that's right. 1 times 8 equal 8, but also there's another two numbers we can get 8. So 2 times 4. Let's take another example. Is 73 a prime number? Yes, as there's no other whole numbers multiplying together to make it 73. So we get 73 only just by 1 times 73. You can do prime numbers activity by clicking in this link, and this slide also you will find it in blackboard. The set. A set is a collection of things. We use capital letters like this one to represent sets. Example, the items you wear is a set. These include hat, shirt, jacket, pants, and so on. So you can write inside curly bracket, this is curly bracket, like this: A equal hat, comma, shirt, comma, jacket, comma, pants, comma, and so on. You can also have sets of numbers, like set of the whole numbers, bracket, curly bracket, 0, 1, 2, 3, and so on. Subsets. When we define a set, if we take pieces of that set, we can form what is called a subset. Example, the set 1, 2, 3, 4, 5. A subset of this one could be 1, 2, 3. Another subset could be 3, 4. Or even another the set subset 1. But the subset 1 and 6 is not a subset of this set. Why? Since it has an element 6 is not included in the parent or original set. A is a subset of B if and only if every element of A is in B. We write like this: A is contained in B, like this one. Look, the set B, this one, is equal to 1, 2, 3, 4, and A is subset from A because it has 1, 2, 3, and 1, 2, 3 is also included in set B. Proper subsets. A is a proper subset of B if and only if every element in A is also in B, and there exists at least one element in B that's not in A. We write A is a proper subset of B. Example, 1, 2, 3 is a subset of 1, 2, 3, but it is not a proper subset because there is not any because all element here is also included here. Look, let's take another example. 1, 2, 3 is a proper subset of 1, 2, 3, 4. Why? Because there is at least one element here, which is 4, not included in the first set. Venn diagram. This is Venn diagram. We can see here the natural numbers is subset of integers, and also natural number and integer numbers both they are subset of rational number. And also rational number and integer numbers and natural number are subset of real number, and all real number is subset from complex number. Empty number. Empty number is a set with no any elements, and it is represented by phi. We pronounce this phi, or empty bracket, empty curly bracket. The empty set is also subset of every set, including the empty set itself. Here there are some notations. This is an element of, and this is not an element of. We use element and non-element for elements only. Example: set of A 1 2 3. We can see here 1, we say element of A. Why? Because it's included in A. But 5 is not element of A. Why? Because 5 not included in A. Notice, dear students, all these topics you have already studied in when you were in school. Power set. Power set is the set of all subsets of a set. Example: for the set A, B, C, the empty set curly bracket is a subset of any set 1, A, B, and C. Also, and these are subset from this one. The set A, the set B, the set C also subset of this set. And these are subset pairwise. A, B, and AC and BC all are subset from parents set. And A and B and C, the set A, B, C also actually subset from itself. And altogether they make power set P of S. So it's include, we put between curly bracket, this curly bracket, and it's empty, and A alone, and B alone, and C alone, and A and B, and A and C, and B and C, and A, B, C, and so on. The number of members of a set is often written as P of S. So when S has cardinality, number elements equal n elements, we write P of S equal 2 exponent n. For example, here how many elements? Here 1 2 3. So 2 exponent 3, it's equal 8. Why? 2 times 2 times 2, so it's 8. So how many elements? How many elements we have? 8. 1 2 3 4 5 6 7 8. Example: what's the power set of for the set 0 1? We get C. How many elements here? 2. So 2 exponent 2 is 2 times 2 4. So we have 4. 1 2 3 4. It will be the empty set, and 0 alone, and 1 alone, and the set itself. You can do power set maker by clicking this link in your PDF when you open, and you should be connected with internet. For basic operation: addition plus to find the sum. For example, 3 plus 5 equal 8. Subtraction minus to find the difference. For example, 8 minus 2 equals 6. Multiplication times to find the product. For example, 17 times 5 equals 85. Division to find the quotient. For example, 437 divide 19 equal 23. Commutative laws. The commutative law says we can swap numbers over and still get the same answer. For example, when we add A plus B, we get equal to B plus A. For example, 6 plus 3, 9. It's equal to 3 plus 9, 3 plus 6. Also we get same answer, 9. Associative laws. The associative laws say that it doesn't matter how we group the numbers, which we can calculate first. For example, when we add A plus B together, then the sum we add with C will get same if we add B plus C, and the sum of it we add with A. For example, here 6 plus 3 alone will give us 9. Plus 4 will give us 13. We get same answer if we add firstly 3 plus 4, 7 plus 6 will get 13, same answer. Distributive law. The distributive law is the best one of all, but needs careful attention. This is what it lets us do. For example, 3 lots of 2 plus 4, 3 lots of 2 plus 4 is the same as 3 lots of 2 plus 3 lots of 4. So the 3 times can be distributed across the 2 and 4. So 3 times 2 plus 3 times 4. And we can see like this one. A times B plus C, we distribute A plus B plus A times C. Example, 3 times 2 plus 4. 2 plus 4 is 6 times 3, 18. Same answer if we distribute 3 times 3, 3 times 2, 6 plus, same plus. 3 times 4, 12. 12 plus 6, 18, same answer. And also here 3 times x plus 3, we get 3 times x, 3x plus 3 times 2, 6. At this point we end this video for week 1. Next video we are going to discuss week 2, and we start by the factors. So see you next week with a new video. Thank you for your listening, and I hope you understand this video.